Hi everyone, hope you are having a good day. So, when you visit a website, you probably enter the website address in your browser's search bar. For example, if you want to visit Retro UI, you go to retroui.dev. You want to go to GitHub, you probably visit github.com, right? We know these website addresses are built for human convenience. They make it easier for us to memorize and remember these website locations. But for your computer to access the website, it needs to know its actual IP address, which is just a unique set of numbers assigned to each website. Thanks to DNS or domain name systems, we don't need to remember these IP addresses. Instead, you can simply visit google.com and DNS will do its job, returning the correct IP address to your computer. Now, if you are a developer or someone technical, you probably know this already. But not many of us actually know DNS, or often described as the internet's phone book, actually work under the hood. And that's exactly what I'll try to unveil in this video, where I will go deep into DNS and show the whole process of how DNS takes a domain and returns you the IP. So yeah, let's get to it. Let's say you typed google.com in your browser. To get the IP address, your browser will first check its internal cache. If it's not there, it will check the operating system's cache. If both the browser and the OS doesn't have the IP cached, the request is forwarded to your DNS server. If the DNS server has it cached, it will return the IP address to your browser and you can visit google.com. Now, what if the address isn't cached anywhere? That's where the DNS hierarchy comes in. But before diving into that, let's first understand what DNS actually is. DNS, or Domain Name System, is a system that translates domain names into IP addresses. It follows a specific set of rules and relies on a network of servers to resolve domain names. There are different software implementations of DNS, such as BIND or Unbound, which are commonly used by ISPs or DNS providers. Now, DNS is actually divided into two major parts: DNS resolver and DNS servers. DNS resolver is responsible for finding the IP address, and DNS server is responsible for storing the domain name records and IP addresses. You can think of DNS resolvers as your librarian who brings you the book on your behalf, and think of DNS resolver as the library who actually stores the book. There are actually multiple levels of DNS servers, and DNS resolver has to go through these different levels to find the correct IP address, and the process it follows is called DNS hierarchy. I know it's a lot to process, so let's take a breath and try to understand the whole thing in detail. Let's say you enter retroui.dev in your browser for the first time. Means there is no cache. So the browser forwards it to DNS resolver, which is a software that's configured in your ISP. By ISP, I mean your internet provider, right? Now, it's DNS resolver's job to find you the IP of RetroUI. The first thing it does is it goes to root DNS server, which is the first level of DNS servers. There are 13 root DNS servers out there, managed by different operators. The DNS server will most likely pick the closest one. Let's say for our case, it picked e.rootservers.net. The root DNS server doesn't know the exact IP of retroui.dev, but it knows which top level domain or TLD server is responsible for .dev domains. Since .dev is managed by Google's TLD servers, the root DNS server returns a list of those TLD servers and returns it to the DNS resolver. Next, the DNS resolver picks one of the TLD server and sends a query for retroui.dev. The TLD server then checks its records and returns the name server or NS record for retroui.dev, which in this case is Cloudflare. Since I actually added retroui in my Cloudflare account, for our case, the TLD server will actually return these NS servers. Finally, the DNS resolver contacts Cloudflare's authoritative DNS server and ask for RetroUI's IP address. The authoritative DNS server responds with A records, and if I show you my Cloudflare admin, you can see RetroUI's IP address is this. Obviously, I am showing you this for learning purposes, so don't go and try to attack my website or something. In a real world scenario, you probably will use Cloudflare to proxy your website. Maybe in some other video, we'll talk about what proxy is and how you can add Cloudflare proxy in your website to help you secure it. Anyways, back to the video. This entire process is called DNS lookup. Once the browser gets the IP address, it caches the result, and that avoids repeating the DNS lookup every time you visit retroui.dev or any other website. The last topic I think you should know of is something called blue record. If you notice the name servers returned from top level domain, this is actually another domain, right? It's not an actual IP. So how will DNS resolver know which authoritative DNS server to call? The answer is, before DNS resolver can go further with retroui.dev, it actually will do a DNS lookup for ns1.cloudflare.com to find its IP. So it will go back to root domain server and then top level domain, and it will return the name servers for ns1.cloudflare.com. Let's say it's x.xx.com, which is also not an IP. So DNS resolver will have to do another DNS lookup to get the IP of x.xx.com, which you can see will not do any help and possibly create an infinite loop, right? And that's where glue records comes in. For many DNS providers like Cloudflare, the top level domain will actually store additional fields like IP addresses along with name servers. So in our case, when DNS resolver calls the top level domain, it will most likely return the name server and also the IP address along with it. Let's say it is 123.2.45.47. So now DNS resolver knows the address of authoritative DNS server to make the request and get the IP for retroui.dev. And that's pretty much how DNS works. Hopefully the video wasn't too boring. I am planning to make more of these low-level tech explainer videos. So let me know if you have any feedbacks. And yeah, see you guys next time. Bye bye.